Question 5. The heights of females from a different country are normally distributed with a mean of 166.5 centimeters, a standard deviation of 6.1 centimeters. Given that 1% of females from this country are shorter than k centimeters, find the value of k. So for part A, we know that the mean is in the middle, and 1% is 0.01 of the area. And to find what k is, we can use our calculators by going to Menu. We can then go to 7 for distributions. We can then press 3 for inverse normal. And for the area, we can put 0.01. For standard deviation, we can input 6.1. We know that the mean is 166.5. And that gives us a value of k as 152. Part B says, find the proportion of females from this country with heights between 150 centimeters and 175 centimeters. So for this, we are looking for the probability of the height being between 150 and 75 centimeters. So to do this, we will again go to our distributions on the menu. This time, we will select number 2 for normal CD. For lower, we will input 150. For upper, we will input 175. The standard deviation is still 6.1, and this gives us an answer of 0.915. The next part says, a female from this country is chosen at random from those with heights between 150 centimeters and 175 centimeters. Part C, find the probability that her height is more than 160 centimeters. So for part C, we are looking for the probability that the female chosen will have a height greater than 160 centimeters, given that we are only choosing from those which have a height between 150 and 175. So using the formula to do this, we are going to find the probability of x being between 160 and 175, because if the height is greater than 160, it can only go up to 175, and we are going to divide by the probability of the height being between 150 and 175. So to do this, we can go back and this time input the lower as 160, the upper will remain 175, and the standard deviation is still 6.1. And this gives us an answer of 0.775. And for the heights being between 150 and 175, we already found that probability in part B, which is 0.915. And if we divide this on the calculator, this will give us an answer of 0.847. The next part says the heights of the females from a different country are normally distributed with a standard deviation of 7.4. Mia believes that the mean height of the female from this country is less than 166.5. Mia takes a random sample of 50 females from this country and finds the mean of her sample is 164.6. Part D, carry out a suitable test to assess Mia's belief. You should state your hypothesis clearly and use a 5% level of significance. So for part D, we can first start by saying, let x be equal to the height of the females from the different country. We can then set our null hypothesis as mu being equal to 166.5, which is what it was. And we can set the alternative hypothesis as mu being less than 166.5, which is what Mia's belief is. So we can now say that the sample mean is normally distributed with a mean of 166.5, and we will write the standard deviation of 7.4 squared and divide it by the sample number, which is 50, which means that the standard deviation is going to be 7.4 divided by the square root of 50. So we are now going to look for the probability of the sample mean being less than 164.6. And to do that, we can again go into the calculator. we can put the lower value as something very small, as minus 1 times 10 to the power of 6. The upper will be 164.6. The standard deviation is now going to be 7.4 over the square root of 50, and this gives an answer of 0.034. We can now compare it to the significance level, which was 5%, and say that 0.0347 is less than 0.05, which implies that the result is significant, and therefore we can accept the alternative hypothesis and reject the null hypothesis. And we can say that there is enough evidence to support Mia's belief that the mean heights of females from the different country is less than 166.5.